Morning. Okay, today we're going to talk about quadratic functions, intro to quadratic functions, what they do, what they look like, how they're made. We're going to identify some things. We're going to identify the axis of symmetry, what the standard form is, how to identify A, B, and C out of standard form. So a lot of stuff is going to go in. Got about 10, 12 minutes worth. Hopefully you can stay with me the whole time. I think you'll enjoy it. First of all, let's talk about what quadratic functions are. Well, they're parabolas. They're upside down U's. They're U's. It depends on what they look like. One, they look like this. It's a kind of a skinny U. This one right here is kind of a little bit bigger U. And then this is a real wide U. Okay. Now they also are the upside down one. Also, they looks like a real skinny mountain, a little bit bigger mountain, and maybe a real big mountain. So those kind of what they look like. Either way, they're upside down or they're not upside down, but they're called parabolas. It's not a real difficult thing for us to understand as long as we can identify A, B, and C. Now, first things first, we've got to identify standard form. So here's standard form. This is what it looks like. Okay. Now with standard form, if you have all the terms there, it makes it real easy. In other words, like this one right here, there's standard form right here. Y equals 2x squared plus 4x minus 7. Well, we need to identify A, B, and C out of all that, okay? Well, A is the coefficient that is with the quadratic term, so it's 2, that's A. B is the coefficient of the linear term, so that's 4. And then C is always a constant. C is easy to remember, C constant. So C is a constant, that's negative 7. So if you can remember A, B, and C, then everything else with parabolas falls into place. If we have A, we have B, we have C, we can do the vertex, we can do the maximum or minimum, we can graph it, we can do everything we want with A, B, and C. Okay, so now let's look at one that doesn't have all the terms in it. Let's look at this one right here. This is y equals x squared plus 3. Well, now we're missing a couple things. First of all, let's identify A. That's what's in front of the x squared, so that's 1. And then B is what's in front of the x. But wait a minute, there's not an x there. So B would be equal to 0. And then C is again the constant, that's 3. Okay? So let's do another one. How about this one? How about y equals 5x squared? Now we're really missing a lot of things. Well, 5, that's the A because it's in front of the x squared, the quadratic term. But there is no B and there is no C. So B is 0 and C is 0. Again, just identify A, B, and C. Should be pretty simple for us. We've had to do that when we're working with quadratics and factoring and whatnot. So it shouldn't be too hard for us. Okay? Great. Okay, so now things aren't always as pleasant and look as easy as those. Sometimes we have where they're out of order. Okay, so how about looking at this one right here? Y equals 2 minus 7x plus 2x squared. It's completely out of order. So we got to put it back in order, okay? So to put it back in order, we'd have to move things around. So there's my y equals, okay? So it'd be 2x squared plus or minus 7x plus 2. So we just took this and we rearranged it so we have the quadratic term, the linear term, and then the constant term. So now once we do that, let's go ahead and label A, B, and C. There's A, 2, B is negative 7, and C is 2. Not a big problem. Okay, let's do another one. How about this one right here? How about y equals 3x minus 4x squared plus 2? Look, again, out of order. So we got to get it back in order again. Got to get it into standard form. Remember, this is standard form right here in case you forget. Okay, so let's get that back in standard form, okay? So y equals, okay? So negative 4x squared plus 3x plus 2, okay? So again, quadratic term, so 4 is my A, or negative 4 is my A. Linear term, so 3 is my B, and my constant is 2, okay? All right, I'm going to bring back standard form right here again. Now watch. Here's something that maybe I forget to tell you, but we've talked about it before. Standard form is where quadratic term, linear term, constant term. And these can be any number they want to be, except this one right here. This one right here, a cannot be equal to 0, ever. It can be equal to anything else, but it can't be equal to 0. Now, b and c can be equal to 0, but not a. So if a is not equal, or if a is equal to 0, then it's no longer a quadratic equation or quadratic function. It's a linear function, because then you just have an x. So we got to make sure that we always have at least a number in front of the x squared. We have an x squared here, we're good to go. We don't have to have anything else. But if we do, a, b, c. Okay, let's talk a little bit about what a, b, and c do with a parabola. Okay, so if we have this function right here, y equals negative x squared plus 6x minus 13. If we look at that, we can say that a was negative 1. Okay, a is negative 1. B is 6. And c is negative 13. So let's see what those do. Okay, well, first of all, we already said that parabolas either open up or open down. Okay, well, a negative number here for a would make the parabola open down. If it's positive, it's going to open up. So those are the two things that a does. Makes it open up or makes it open down. And you'll see me do up and down all the time. Okay, let's go to c. Let's skip to c. C is where this parabola crosses the y-axis. It's the y-intercept. So if I were to graph this right here, it would cross the y-axis at negative 13. That's kind of important. We know that if we're graphing it and it doesn't cross at negative 13, we've done something wrong. Okay, and then b makes the parabola move. Now, I'll show you b later on. It's a little bit more difficult to show you, but if you know that a tells me it opens up or down, positive opens up, negative opens down. C is where it crosses the y-intercept. Those are the two most important things that you can understand from labeling A, B, and C. Okay, so let's kind of recap what we've talked about so far. We've talked about standard form and what it looks like. We've talked about how to identify A, B, and C. Okay, so now we're going to talk about a new thing. It's called axis of symmetry. A lot of people abbreviate that by AOS, axis of symmetry. Well, here's the axis of symmetry equation. X equals negative b over 2a. Now, wait a second. You're asking, where do I get the b and where do I get the a from? Well, you get it from the a, b, and c that we already identified. Pretty nice, pretty simple. Again, once you identify a, b, and c, everything else falls into place. Okay? So we have this other equation that we've already used. Y equals negative x squared plus 6x minus 13. Let's use it again. First of all, we said that a was negative 1, b was 6, and c was negative 13. So if we take those and put them back into this formula right here, x equals negative b over 2a, then we're going to get the axis of symmetry. I'll tell you what it does here in a minute. It's kind of a surprise. Okay, so I'm going to put it in. X equals negative b. So now it always looks like this. And then I just have to put what my b is here and what my a is there. My b is 6 and my a is negative 1. Okay? So negative 6 divided by 2 times negative 1, or negative 6 divided by negative 2, which is x equals 3. So x equals 3 is my axis of symmetry. Now here's a key. Your axis of symmetry will always be x equals. Because if you remember, going back to linear equations, when it's x equals, we know it's going to be a vertical line. And when it's y equals, we know it's going to be a horizontal line. Well, we know this is going to be a vertical line. Because this axis of symmetry, the AOS axis of symmetry, what it does is it cuts the parabola in half, right down the middle. So you could take that parabola, fold it in half right on the axis of symmetry, and it's going to look the same on both sides. So whenever you give the axis of symmetry, it's always going to be x equals and then a number. This parabola is going to be, the center of the parabola is going to be at x equals 3. So if you go out on the y or the x-axis out to 3, put a dotted line, that's where your parabola is going to be cut in half. Okay, let's try another one. So let's try this one right here. Y equals x squared minus 2x plus 3. Okay? First of all, before you do anything, Is it in standard form? Yes. Second, let's identify A, B, and C. So A is 1, B is -2, and C is 3. Good job. All right, so now you identified A, B, and C. Let's go back and remind ourselves. Remember, this is how we find the axis of symmetry. Okay, so there's the axis of symmetry formula. Let's go back and figure it out. So it's going to be x equals negative b over 2a. So b and a go here. So b, now be careful in these. See how b already has a negative? Well, this negative has to come in also because we're just putting in b, which is -2. Okay, and then 1. So -2 gives me 2 divided by 2, which is x equals 1. So when we graph this parabola, the axis of symmetry, the AOS, is going to be at 1. Okay? Now, go back and look at this parabola. Let's see what we can do. So we can do the AOS, the axis of symmetry. We know that it's going to open up, and we know that it's going to cross the y-axis at 3. Okay? Now, when we tell it where it crosses the y-axis, we're actually going to say 0, 3. It's going to be a coordinate. So it's going to cross the y-axis at 0, 3. We can tell all that stuff just by finding A, B, and C. A, 1, B, -2, C, 3. All right, let's do another one. Now, this is a little bit trickier. We're going to do this one right here. Okay, y equals x squared. Now, this is a unique one, so we'll have to work through it. We'll be fine. But there's something special about this one. We'll talk about that after we find A, B, and C. Okay, so y equals x squared. So A is what's in front of the x squared, so A is 1. But wait a minute. We're missing B and we're missing a C. So B's not there, we say B is 0, and C is not there, so we say C is 0. Okay? Axis of symmetry, remember. Here's how I find the axis of symmetry again. Okay, so x equals -b over 2a. And we said b was 0 and a was 1. So -0, that just means 0. So 0 divided by 2, which is x equals 0. So in other words, that axis of symmetry is going to be the y-axis. It's going to go straight up and down the y-axis. That's the axis of symmetry. So let's go back over and find out what A, B, and C are. So if A is 1, remember it's going to open up because it's positive. B is 0, and C is 0. Wait a second, if C is 0, that means it's going to, the y-intercept is going to be 0, 0. Remember, this is x and this is y. So the y-intercept is going to be 0 again. So 0, 0. Okay, that makes sense. You know what all this is called? This right here, this formula, or this function right here, it's called the parent function for quadratics. Parent function. That means all the other functions build off of this guy right here. Okay? So all the other functions build off of y equals x squared. All right, so if we have a parabola that opens up, this is going to have a minimum. It's the lowest point on the parabola. If we have a parabola that opens down, this is going to have a maximum point. Okay? Now, in the next video, these 2 points we're going to name. Okay? We're going to name these in the next video, but for now you need to know that opening down has a maximum, opening up has a minimum. Okay, the last thing we're going to talk about today is minimum and maximum. Okay? Minimum is the lowest part of your parabola, and maximum is the highest point of your parabola. Okay? So if I give you this parabola right here, does it have a minimum or a maximum? If I give you this parabola, minimum or maximum? And how about this guy? Minimum or maximum? Good. Okay, now make sure you understand, we don't deal in Algebra 1 at Highland High School, we don't deal with these kind of parabolas or this kind of parabola. That's not what we deal with. We only deal with opening up and opening down. Hey, before I forget, I want to tell you 2 things. One, I made a TikTok, and the TikTok is going to be very simple. It's just going to explain basically what I explained in this video, but just real quick, what standard form is, how to find vertex, what maximum and minimum are. So it's just going to be real quick. They're not going to be real fancy, just kind of me talking in front of a whiteboard. And also, I'm kind of an older guy, so I still use Twitter. You can use both of these. Look at Twitter. If you got questions for me, send me a tweet, and ask me questions. It'll be just for our algebra kids, Mr. Cozy's kids, and my kids will be on both of those. So here again is my TikTok, and here's my Twitter. And hopefully you'll find this exciting and not too painful, and we can get through this. Stay safe. We'll talk to you on another day.